Question number 36 says, if source and detector both are moving in same direction with same speed, then we can say that the relative velocity will be what? 0. So according to the Doppler effect, the apparent frequency will be different whenever there is a relative motion along the line joining the source and observer. Since there is no relative motion, so the apparent frequency will be same as original frequency. So equal to original frequency. Option 3 will be our correct choice. Now let's move to the question number 37. In question 37, it says that a car while whistling a frequency of f is approaching a stationary wall with velocity v. The velocity of sound in air is c. The number of beats heard by the driver per second is. So let's say this is our car moving towards a stationary wall with speed v. And let's say this is our driver. So the sound heard by the driver will be two types. First, which is directly coming from the car, and second, the reflected from the wall. So driver will hear two kind of sound. One is directly from the car and other is reflected from the wall. So the frequency which is heard directly from the car will be equal to the original frequency of the car, that is f. Now what about the reflected one? So first the sound will move from the car to the wall. So from the car to wall. So since sound is moving from the car to the wall, so we can say that the velocity of the source will be equal to the velocity of the car, that is v. And since the velocity of the sound and the velocity of the car is in same direction, so this will be positive. And here the wall will behave like an observer, so velocity of the observer will be 0. So the frequency received by the wall will be equal to, from the Doppler's formula, c minus v0 upon c minus vs into original frequency. So if I put the values, we will get c minus 0 upon c minus v into original frequency, and that will be equal to c upon c minus v into original frequency. So this is the frequency received by the wall. Now the sound will get reflected from the wall to the car. So let's write from the wall to car. So when the sound is moving from the wall to the car, we can say that our velocity of the source, that is the wall, will be equal to 0. And the velocity of the observer, that is the car or driver, will be equal to minus v. Why minus v? Because now the velocity of the sound is towards left and the car is moving towards right. So they are in opposite. So minus v. So we can say that the frequency heard by the driver will be equal to, from Doppler's formula, c minus v0 upon c minus vs into original frequency. Here the original frequency is the frequency reflected by the wall, and we know that frequency reflected by the wall will be equal to the frequency received by the wall, that is f dash. So if I put the values, we will get c minus v upon c minus 0 into c upon c minus v into f. So by solving this, we can say that our frequency heard by the driver will be equal to c plus v upon c minus v into f. So these are the two frequencies. First one, this is directly heard by the driver, and this is the frequency of the reflected sound. So we know that number of beats is equal to the frequency difference, modulus of the frequency difference. Why modulus? Because the beat should always be positive. So if I put the values, we will get f minus c plus v upon c minus v into f, and by solving this, we will get 2vf upon c minus v. So from this, we can say that our option number 4 will be the correct choice. Now let's move to the question number 38. In question number 38, it says that two forks A and B, when sounded together, produces 2 beats per second. So that means frequency of A minus frequency of B will be equal to 2. Now the question says the fork A is in unison with 30 cm length of sonometer wire, and B is in unison with 25 cm length of the same wire at the same tension. So if the wire is same, tension is same, so the velocity will remain same. Only the length is different, and we know that the frequency of a sonometer wire is V by 12. So we can say that frequency of the fork A will be equal to the V by 2 into 30, because it is in unison with 30 centimeter length, and frequency of B will be equal to V by 2 into 25. As you can see that frequency of A is lesser than frequency of B, so this equation should be modified to FB minus FA is equal to 2, right? So this is our equation 1. Now if I divide FA by FB, how much you will get? So if I divide FA by FB, we will get 25 by 30. That means 5 by 6. So if I use this equation, equation 2 in equation 1, we can write FB minus 5 by 6 FB will be equal to 2. So FB will be equal to 12, right? So if FB is equal to 12, we can write FA will be equal to FB minus 2, and that will give you 10 Hertz. So now we can say that the frequency of A is 10 Hertz and frequency of B is 12 Hertz. So my option number 2 will be the correct choice. Now let's move to the question number 39. In question number 39, it says that 3 waves y1 is equal to 2a sin omega t minus pi by 3, y2 is equal to 2a sin omega t plus pi by 3, and y3 is equal to minus a sin omega t interfere each other. The amplitude of the resultant wave is. So we can use simply vector diagram or phasor diagram to solve this kind of question. So let's say this is our x-axis and this is our y-axis. So according to the question, the first wave has amplitude 2a and phase minus pi by 3. So we can say that our first wave will be in this direction. Amplitude is 2a and angle is minus pi by 3. So minus pi by 3, it will be below the x-axis. So this is pi by 3. Now the second wave has amplitude 2a and phase is plus pi by 3. So we can say that our second wave will be in this direction. Will have a amplitude 2a and again the angle is pi by 3. Since plus pi by 3, so it will be above the x-axis. And the third wave has amplitude a with negative sign. That means a will be in this direction. That will be minus x-axis. So this is our a. So as we can see that this 2a and 2a will have two components. So this 2a will have one component in this direction, right? So how much will be this direction? 2a cos pi by 3, and this one also will have 2a cos pi by 3, right? One component is in this direction, that will be 2a sin pi by 3, and in this direction also 2a sin pi by 3. So as you can see that this 2a sin pi by 3 and this 2a sin pi by 3 will cancel out. So we can say that this 2 minus this will be our resultant. So we can say that our A resultant will be equal to 2a cos pi by 3 plus 2a cos pi by 3 minus a. So cos pi by 3 is 1 by 2. So you will get a plus a minus a, that will give you a. So our resultant amplitude is a. So my option number 1 will be the correct choice. Now let's move to the question number 40. In question number 40, it says that two particles undergo SHM along same line with same time period and same amplitude. Line is same, time period is same, amplitude is same. At particular instant, one particle is at x is equal to minus a and other is at x is equal to 0. If they move in same direction, then they will meet each other at. So we can write the equation of SHM by looking at this diagram. Since the first particle is x is equal to minus a, that means at extreme position with negative sign. So we can say that equation of this particle can be written as minus a cos omega t, because at t is equal to 0 it is at minus a, and the second particle which is at mean position is moving towards positive direction. So we can write the equation of SHM as a x2 is equal to a sin omega t. So this is the equation of SHM for these two particles. But question says they will meet each other. So they will meet each other, that means their position must be same. So that means minus a cos omega t must be equal to A sine omega t. So by this we can say that tan omega t will be equal to -1, since this A will cancel out. So from here we can say that omega t will be equal to 3 pi by 4, because we know that at 135 degree tan will be negative. So now we know the value of omega t, so we can write the value of position x2, that will be equal to A sine 3 pi by 4, and we know that sine 3 pi by 4 is how much? 1 by root 2. So the answer will be 1 by root. So we can say that our option number 2 will be the correct choice. Now let's move to the question number 41.